I'll be talking about geometric probabilities.
And I'm Michelle Stoll, and I'll be talking about binomial probabilities.
Binomial and geometric probabilities are used to calculate a variety of things, including the probability of when a success will occur and the probability of a specific number of successes within a series of trials. This makes them very important in calculating things in daily life.
So these statistics can be broken down into two parts, PDF and CDF. PDF is more specific because it uses a certain amount of successes and/or trials. CDF is more broad because it uses on or before or specific or fewer, which means within a set amount of trials, there will be a certain amount of successes or fewer. Now let's get down to the details.
Every PDF has a corresponding CDF. CDF stands for Cumulative Distribution Function. To find this function in your calculator, start by pressing Second Distribution. Then, key your selector down to Option B. Option B is labeled Binom CDF. You can also find the CDF function in Genom CDF. Scroll down to label F. PDF stands for Probability Density Function. To find the PDF function in your calculator, select Second Distribution and scroll down to Option A, Binom PDF. You can also find PDF in the Genom function by scrolling down to Option E.
Geometric probability focuses on the probability of when a success will occur. This can include on the nth trial or on the nth or before trial. So, either way, you're going to be using a special format on your calculator. So for Genom PDF or CDF, it's going to be P, N, where P is the probability of success and N is the number of trials. But how do you know when to use PDF or CDF? Well, for PDF, it's going to be on the first success on the nth trial, and you're going to be trying to find the probability of that. Let's go ahead and see an example. 30% of people over the age of 16 that go to parks bring children with them. Now if we examine, say, 6 of these people, what is the probability that the 6th person is going to bring a child with them to the park? What we're going to need is a statistics called geometrics. Now for this case, we're going to be using PDF. And you're going to be looking at two important numbers, the percentage of the probability and the number that you want. So you're going to be looking at 30%, which in decimal form is going to be 0.30, and the 6th one. So Genom PDF of 0.30, 6. Let's calculate. Now what about CDF? Well, it's going to be the first success on or before the nth trial. Let's go ahead and see an example of Genom CDF. This restaurant serves 4 types of pizzas: cheese, pepperoni, vegetarian, and combo. What is the probability of getting a cheese pizza by the 10th order? To calculate this, you're going to be using Genom CDF. You'll be focusing on two important values: 0.25, which represents 25% since you're calculating for 1/4 of the types of pizzas. Also, you'll be using 10 for by the 10th order. Your final will be Genom CDF of 0.25, 10.
Binomial helps you figure out the probability of a certain number of successes within a certain amount of trials. For both CDF and PDF, we are going to use the command binom CDF or PDF, n, p, x, with n being the number of trials, p being the probability that a success will occur, and x being the successes that you want to happen. But how do you know whether to use binom CDF or binom PDF? Well, binom CDF is a probability of specific number of trials and a specific number of successes. Let's see an example of that. Since some people, Tori, are stupid and don't go to the doctor when they have an eye infection, their eye gets all gross and they need an eye patch. 2% of people who come into the store buy eye patches. We take a random sample of 15 people. What is the probability that no more than 5 of those people are extremely stupid? For this situation, we are going to use a binom CDF. Since we're taking a random sample of 15 people, and the probability that they are really stupid and buying an eye patch is 2%, putting that, and then we are hoping no more than 5 of those people are really stupid. So our final equation is going to be binom CDF 15, 0.02, 5. Let's calculate.
Thunderbolt and lightning, very, very frightening me. Galileo, Galileo, Galileo figure.
To use binom PDF, you have a certain number of trials and you have a certain number of successes or fewer. Now let's see an example of that. 45% of people who have symptoms for an eye infection do not go see a doctor immediately. If we have 20 random people who have symptoms for an eye infection, what is the probability that 7 of those people will not see a doctor immediately? To solve this question, we are going to use binom, and we are going to use PDF. Because it is a definite answer. So, there are 20 people, and there is a 45% chance that they do not go see a doctor. Out of those 20 people, what is the probability that there will be 7 that won't go see a doctor immediately? So for the final calculation, you're going to put into your calculator binom PDF of 20, 0.45, 7. Let's calculate.
You are sure to win. You're a spineless, pale, pathetic lot, and you haven't got a clue.
This is Wendell's theorem. It is a probability theorem that is used with geometric probabilities. Quoted from J.G. Wendell's A Problem in Geometric Probability. Let n points be scattered at random on the surface of the unit sphere in n space. The problem of the title is to evaluate p to the under n, the probability that all the points lie on some hemisphere. Probability curves come from probability theory, which is an aspect of mathematics that focuses on calculating probabilities. They are also known as normal distributions or Gaussian distributions.
Binomial and geometric probabilities can both be extended into normal curves.
Both of them will use some of the same values that we have, but a new value will also be introduced, which is Q, the probability of failure.
Some of the old values are n equals number of trials, p equals the probability of success, and x equals the number of successes in n trials.
There will also be some new calculations being introduced. Mean, which is n times p, and the standard deviation, which is the square root of n times p times q.
These normal distributions are created using a function called normal. Like binom and genom, it is broken down into CDF and PDF, depending on what answer you are after. So, by selecting second distribution and scrolling down to either option 1 or 2, you can use your calculator to help you calculate answers necessary for creating a normal distribution from binom and genom, PDF, and CDF.
And that's what you can do with binomials.
And that's what you can do with geometric. Thanks for listening.
Hey, I heard you were a wild one. I took you home and be a woman, show